Hello. In this video, we are going to learn how to combine all the different parts of a quadratic that we've been learning about so far. So what we're going to do is we're going to start with the equation y equals x squared plus 6x plus 8. And we're going to find all these different parts of the quadratic so that we are able to graph it and then find the domain and range. So the first thing that we want to do is convert y equals x squared plus 6x plus 8 into vertex form. So if you remember, when we're converting to vertex form, we want to put it in this format. This is our vertex form format. So to get the number that's inside the parentheses, what we're going to do is we're going to divide the middle number by 2. So positive 6 divided by 2 is positive 3. And then we're going to square that, and we're going to subtract it from the last number. So 8 minus 9 is negative 1. Therefore, our vertex form equation is y equals x plus 3 squared minus 1. So now that I have it in the vertex form equation, what I can do is I can write the vertex, which is at negative 3, comma negative 1. Because remember, we take the opposite of the number that's inside the parentheses, and then we keep the last number. We can also find the y-intercept, and that's actually going to be the last number of our original equation. So that's going to be 0, comma 8. The next thing that we want to do is to find the x-intercepts. So our equation is y equals x squared plus 6x plus 8. In order to find the x-intercepts, what I need to do is factor. So I'm going to go ahead and set up my box and diamond. So x squared goes here, 8 goes there, 8x squared up on top, 6x on bottom. So we're looking for two numbers that multiply to 8 and add to 6. That's going to be 4x and 2x. 4 times 2 is 8, 4 plus 2 is 6. So 4x and 2x. Now I need to figure out what goes on the outside of my box. So I'm going to break apart the x squared to be x and x. Then I have 2 here because x times 2 gives me 2x. And then 4 here because x times 4 gives me 4x. And just a quick double check, 2 times 4 is in fact 8. So we know that's good. Now since I'm trying to find the x-intercepts, I'm going to solve for x. So I'm going to go ahead and take x plus 4 equals 0. Subtract 4, I get x equals negative 4. So one of my x-intercepts is negative 4, comma 0. And then the other one is x plus 2 equals 0. Subtract 2 from both sides. I get x equals negative 2. So my other x-intercept is negative 2, comma 0. So in order to find the x-intercepts, what you have to do is factor. So now what we have is enough information in order to be able to graph our quadratic. So what I'm going to do is first plot my vertex. So I'm going to plot negative 3, comma negative 1. So that's going to be this point right here. And then I have negative 4, comma 0 and negative 2, comma 0 as my x-intercept, so I can go ahead and plot those. And then I also have my y-intercept of 8. So 1, 2, 3, 4, 6, 7, 8. So that's going to be right here. And then I also know that parabolas are symmetric. So I can also plot the same point over here because it's going to be symmetric on both sides. So then I'm going to go ahead and connect these 5 points and draw my parabola. So we were able to do all the algebra to find the vertex, find the y-intercept, find the x-intercepts, and that gave us enough information to be able to graph our parabola. So the last thing that we want to do is state the domain and range of the graph. The domain, because we have arrows on both sides of our graph, we can write it one of two ways. We can write negative infinity is less than x, which is less than positive infinity. You could also write all real numbers. Because our graph is going to include every single x value, which means we can plug in any x value that we want into the equation and we're going to get something out. There are no x values that are off limits. For the range, our lowest point is -1, which is going to be included, and then it continues going on forever and ever. So we can write it as -1 is less than or equal to y, which is less than positive infinity, or you could also write it as y is greater than or equal to -1. So in this problem, we were able to, like I said, use algebra in order to be able to find all the different parts of the quadratic, to be able to plot it, and then find the domain and range. Thanks for watching.